Alright guys, welcome back after that short advert break. Let us now put what I've said in the first part of our lesson and we basically incorporate it by doing some questions, right? Some mathematics. As I've indicated, we are looking in our lesson today at body mass index, and now we're moving by looking at some examples. Okay, so at question number 1, I said use the formula BMI equals to mass in kilogram divided by your height in meters to answer the questions, right? So now question number 1A, it says here that Roger has a mass of 63 kilograms and he is 1.6 meters tall. Calculate his BMI and round your answer to 2 decimal places. All right, now the people that joined us previously, they will know. I believe we start with the formula first, right? Second step is we substitute. Step number 3, we simplify. Step number 4, we write our final answer in its simplest form and according to the context. In this case, it must be rounded to 2 decimal places and with the correct unit. Now let us put that all into practice. So I must calculate his BMI. So I'll start by indicating that BMI equals to my mass in kilograms divided by my height in meters squared, right, as indicated there. So I'm done with step 1. Step 2, I'm going to substitute. Looking at what is presented here, okay, I see that his mass is 63 kilograms, right? His height is indicated that he is 1.6 meters tall, and remember to square this value, okay? So now I will simplify by typing in 63 divided by 1.6 and I'll square that value. So looking at my calculator, it will give me an answer of 24,609,375. All right? Now I will quickly go back to this part that says round your answer to 2 decimal places. So therefore, I will indicate that this is 24,61. I looked at that 9, right? So that 0 become a 1. And remember, I said correct unit. What are we calculating? BMI. So therefore, I'll say it's 24,61 kilograms per square meter. Right? Guess that's straightforward to all of us. Okay, so I took the weight, I divided it by its length, and remember to square, and thereafter I had to round off. Okay, let us look at another question. So at question number 1B, we are saying Rose has a mass of 95 kilograms and she is 168 centimeters tall. Determine Rose's BMI correct to the nearest whole number. I'm going to go through that same 4 steps, right? We need to determine BMI. So therefore, I'll indicate body mass index equals to my mass in kilograms, and I'll divide that by my height, right? And that must be in meters, and I'll square that value. Now I will look, and I want quickly to pay attention to this part here. If you look at what our formula is indicating, that our height should be in meters squared, right? But now here, the height is given in centimeters, okay? So therefore, we know 100 centimeters equals 1 meter, so therefore I need to divide this by 100, okay? So I'm quickly going to indicate that the weight is 95 kilograms, right? So 168 divided by 100, so that should give us then 1,68, and that's now meters. Guys, are we clear on that? I had to do that conversion, right? And don't forget to square this value. Now I'm going to simplify by saying 95 divided by 1.68 squared equals to. So this now gives me a body mass index of 33,65, and it gives me some other digits as well. I'll stop there because I need to round off correct to the nearest whole number. So therefore, the BMI in this case will be 34 kilograms per square meters. Guys, are we clear on this? Please be on the lookout for things like this given in centimeters. So just to go through this again, I took my mass of 95 kilograms, I divided it, before I divided it by my unit or my weight, my centimeters, I converted the centimeters to meters, right? Because the formula requires the height in meters. And then I rounded off at the end to the nearest whole number. All right, hope that's fine. Let us now move on to our next question. So at number 2, we are saying Jack weighs 70 kilograms and has a BMI of 24,22 kilograms per square meters. Determine his length, right, in meters. All right, so can you see slightly different? Nah. Okay, so therefore always start with what is given to you. So it says you may use the formula BMI equals mass in kilogram divided by your height in meters. So remember step 2, substitute. In this case, please note the BMI is given, right? So therefore, and I'll continue here, there's my formula already. I'll indicate that the BMI is 24,22 kilograms per square meter. Equals to, do I know what his mass is? Yes, he weighs 70 kilograms, right? So therefore, I'll indicate 70 kilograms, right? And remember, I am looking for his height, right? And that is in meters squared. Are we clear on that? So that's the first step I substituted. But looking at this, since I'm looking for his length, I need to change the subject of the formula. His length or his height, basically, right? Same thing. So therefore, I will make the height the subject of the formula. So it's height in meters squared, right? Equals to 70 kilograms divided by your 24,22. Okay, so 70 divided by 24.22. So that will give me, and now I'm going to keep this as height in meters squared. Right? I simplified only this part so far. So that will give me 2,89017341. Let's check that I copied correctly from my calculator. So it's 2,89017341. All right, so that's what I see now. Remember, I need my height or the length in meters, but for now there's still meters squared. So therefore, I will indicate then that the height in meters, can you see now, I didn't indicate the square there. As soon as I do that, do the inverse here. So I'm going to determine the square root of 2,89017341. All right, so let's determine the square root of that. So looking at that, after I determine the square root, I'll get an answer of 1, and I'm going to round off to 2 decimal places, 70. And remember, I can indicate there that's 1,70 meters. Guys, let's run through this again. In this case, the BMI was given. I substituted correctly. I changed the subject of the formula because I was looking for the height in meters, right? So as soon as I simplified this part here, I ended up with 2,89017341. There was still my square. In order to get rid of that square, if I can put it that way, I did the inverse, right? I calculated the square root of 2,89017341. I've ended up with an answer of 1,70 meters. Guys, I hope that's fine to all of you. Let us quickly look at another question. So here I'm saying Bootle is a 20-year-old female who weighs 58 kilograms and is 1,24 meters in height. Use the formula and the BMI classification table to classify Bootle's weight status. Right, so there's the formula, and there is your classification table. Now let's quickly do this one. I'll use the formula there, step 1. Let's substitute. What is the mass? That is 58 kilograms. We agree? Then I'll divide this by the height in meters squared. The height here is 1,24 meters, and I squared that value. Now let's go to our calculator. 58 divided by 124 squared equals. So that will give us a BMI of 37,7, right? Kilograms per square meters. Now we have our BMI. We have to classify, right, her weight status by looking now at the table. So where will we find 37,7? That's more than 30, no? We agree. So in this case, we will conclude by saying Bootle is obese. Guys, are we clear? So we found the BMI, and based on our answer there, we went to the classification table, we saw it's more than 30, and we indicated that she is obese. All right, guys, let us take a quick advert break. After the break, we'll do some more sums. See you now.